Good morning. In this video lesson, we are going to cover OMHS 104, multiplying and dividing in scientific notation. So that is our learning target. Our goal is that by the end of this video and then the activity that follows, that you will be comfortable and confident in your ability to multiply and divide numbers that are written in scientific notation. And of course, if you end the lesson and activity with questions, make sure you attend a help session or send your teacher an email. But first, let's do a little exponent review. So I'm going to read this sentence and pause and see if you can fill in the blank. So when you are dealing with exponents, so think back to those lessons before we started scientific notation. When you are multiplying powers with the same base, what do you do to the exponents? So if we wanted an example, if you're multiplying powers with the same base, what do you do to your exponents? Hopefully you said add. Our shortcut, our property tells us that we can add those exponents. All right, how about this second one here? When you are dividing powers with the same base, the exponents are so for an example, if we had 7 to the 10th divided by 7 to the 4th, hopefully you said subtracted. Those exponents are subtracted. So 10 minus 4 is 6. All right, it is important that we remember these properties because we are going to be integrating them. We are going to be using them here in a second when we multiply and divide numbers written in scientific notation. All right, let's start out with a multiplication problem. What we have here are the steps are written out in words off to the left, and then we're going to work it out together on the right. So the problem that we're given is 2 and 75/100ths and 10 to the negative 8th is being multiplied by 4 and 6/10ths and 10 to the negative 3rd. So the first thing that we want to do is we want to group together our number terms. You've also heard me call those our coefficients and our power of 10 terms. So we're going to regroup these because that's one of the beauties of multiplication is we have a property that tells us when it's pure multiplication all the way across, you can do some regrouping. So our number terms here, otherwise known as our coefficients, we're going to group those. And then I'm going to use parentheses for multiplication so I don't get that dot confused with my decimals. And then we're also going to group our power of 10 terms. I like to do that regrouping step because it helps me visualize that we're dealing with each piece separately. Now for step 2, we are going to go ahead and multiply our power of 10 terms. Let's do the faster one first. Well, we just reviewed our exponent properties because we have 2 power of 10 terms here, and they have exponents. We have the same base, and they're being multiplied. So what do we do to our exponents? Add them. Negative 8 plus negative 3 would be a negative 11. And that's it for step number 2. Now on to step number 3, we're going to do the multiplication for our number terms. This is something that if the numbers are smaller as we have here, we want to multiply by hand because these questions could come up on the non-calculator portion of your testing. So make sure that you do it by hand, okay? If you always want to double check your work at the end to make sure you didn't make a mistake, I'm okay with that, but do the actual multiplication by hand first. As a little refresher, when you're multiplying decimals, we do not have to line up the decimal point. We set up our multiplication like we would a normal multiplication problem, and then we deal with the decimal points at the end. So because of that, we kind of ignore the decimal point, and I look at this as 275, and I look at this as 46 to help me make sure I set it up with the proper number on top. And then we'll just go ahead and do our multiplication like normal. I'll go ahead and work this one out just to make sure we all remember how to do that. So you first start and you multiply everything by that 6. So 6 times 5 is 30. Carry the 3, bring down the 0. Then 6 times 7 is 42. And add the 3, giving us 45. 6 times 2 is 12. Add the 4, giving us 16. And because that was our final number, we can write the whole thing down. Now, before we move forward and multiply everything by this 4 here, what do we need to put down? Make sure you skip a space, or I'm sure most of your teachers probably encourage you to put a 0 as a placeholder because we're moving over a place value. So we need to bump over a place value when we write all of our numbers. So now we'll multiply everything by 4. 4 times 5 is 20, carry the 2. 4 times 7 is 28, plus 2 gives us 30. 4 times 2 is 8, plus 3 gives us 11. And we're going to go ahead and even add these up before we even mess with our decimal points. So 0 plus 0 is 0, 5 plus 0 is 5, 6 plus 0 is 6, 1 and 1 is 2, and nothing plus 1 is 1. Now, to properly place that decimal point, I need to look back into my problem. And I notice in my first number here, I have 2 digits that follow my decimal point. So 2 numbers to the left, or sorry, 2 numbers to the right. Get my directions mixed up here. And then in our second number, we have 1 digit that follows our decimal point. So 3 numbers, so 1 number to the right. Whew. Let me back that up. Sorry, I'm getting ahead of myself in my brain. So in the first number, we have 2 digits that follow the decimal point. In the second number, we have 1. We're going to tally that up, giving us 3, meaning in our final answer, we need to move that decimal point 3 times. Or another way to look at it is we'll have 3 digits following the decimal point. That places us right here. Now let's go ahead and put all of this back together. So that means we have 12 and 65/100ths, because now I can drop that 0, times 10 to the negative 11th. And step 4 says, if necessary, rewrite in proper scientific notation. What do you think? Do I need to rewrite this one? I sure do. What is wrong with this? Why is this not considered being written in proper scientific notation? Is our coefficient right here, our number term, 12 and 65/100ths, doesn't meet our scientific notation requirements. And that requirement is that coefficient, that number term there, has to be greater than or equal to 1 and less than 10. And 12 and 65/100ths is not less than 10. Do you remember how to fix that? We fix that by moving our decimal point. Currently, so this is going to be step 4 here, we're rewriting it in proper scientific notation. So if we look at this, if I moved it one way to the right, that would make my number 126 and 5/10. That's not less than 10. Therefore, let's undo that. Not the right direction to move the decimal point. But if I added a decimal point, if I moved it up 1, that would give me 1 and 265 thousandths. Does that meet our requirements? It sure does. That number is greater than or equal to 1 and less than 10. But make sure you remember that because you added a decimal point, our exponent needs to change. You remember in scientific notation, those exponents have a special meaning. They tell us how many times that decimal point was moved. So if we moved it up 1, if we added a decimal point, we need to add 1 here. And what would be negative 11 plus 1? Negative 10. So our final answer here is 1 and 265 hundredths times 10 to the negative 10. To do a quick little recap of our steps, because my paper is full of work, take a deep breath. Hopefully you see that this is easier than all the jumbled work here, because what you need to do is you simply multiply your number terms, multiply your power of 10 terms, put it back together, rewrite if necessary. So we multiplied our decimals here, we multiplied our power of 10 terms here, put it all back together, and we have our solution. All right, let's do a division one next. You're actually going to find that when we divide in scientific notation, it's the same thing, it's just we're dividing instead of multiplying. So our basic steps are going to be just what we did for multiplication, where we're going to divide our number terms, we're going to divide our power of 10 terms, and then put it back together again. Let's go ahead though, and since this is your first example, and go through each step one by one so you can follow along. All right, step number 1 tells us to group our number terms and our power of 10 terms. So our number terms, otherwise known as those coefficients, are these right here. And then our power of 10 terms are right here. We've grouped those together. We've pictured those separately. The reason for doing that is so we can do step 2 and step 3. It doesn't really matter which one you do first. I just kind of like doing the quicker one first. I think dealing with the exponents is a little bit faster. So we're going to divide our power of 10 terms. We have 10 to the 9th being divided by 10 to the 3rd. Remember that when you divide exponents, when they have the same base, which we do here, you subtract your exponents. 9 minus 3 gives us 6. And if we wanted to, we could just write the answer down here, 10 to the 6th, so I don't lose that in other work. All right, let's move on to step 3. We now need to divide those number terms. I think the biggest thing here is making sure that you guys remember to set up your long division properly, because we have 4 8/10 over 3. Another way to say that is 4 8/10 is being divided by 3. That means 4 8/10 is being divided by 3. So whenever you have a fraction and you divide that fraction, the numerator is your dividend. It goes on the inside. Your denominator is always your divisor. It's what you're dividing by, therefore it goes on the outside. All right, thankfully this is one where the number we're dividing by isn't a decimal, so I can just get straight into my division. How many times can 3 go into 4? 1 time, and 3 times 1 is 3. That's what we're going to subtract. 4 minus 3 is 1. Bring down your 8. How many times can 3 go into 18? 6 times. And 3 times 6 is 18, meaning it goes evenly. And we don't have anything else. But there's something I'm forgetting, and this is something you should do right away so you don't forget. When you're dividing with decimals, you just gotta bring that decimal straight up so you don't forget about them. And that's really all you gotta do. All right, step number 4 tells us to write it in scientific notation. We're gonna put our two pieces back together. 1 6/10 times 10 to the 6th. Do I need to do any rewriting, or is this already in correct standard notation? Or right in standard notation, I got a typo. That should say scientific notation. Sorry about that. So is this in proper scientific notation? It sure is, because that coefficient right here, that number term, 1 6/10, is greater than or equal to 1 and less than 10, giving us our final answer. All right, we're actually going to do one more division problem because I do want to make sure you guys remember what to do when you are dividing by a number that is also a decimal. So here we have 0 8/10 times 10 to the 0 power being divided by 0 400 times 10 to the negative 6 power. So remember, when we're multiplying or dividing in scientific notation, either operation, we deal with our number terms, then we deal with our power of 10 terms. We do each one separately and then put them back together. So first, let's do what I consider the easy one because it's just a little bit faster. And let's deal with our power of 10 terms. So we have 10 to the 0 power being divided by 10 to the negative 6 power. Well, the way that we simplify this, because their bases are the same and they're being divided, is I subtract my exponents. Whenever you're subtracting exponents and a negative is involved, be careful. Whenever this happens, I personally write it out because I struggle with mental math and I'm more of a visual person, so I need to see it to make sure I don't mess up my subtraction and my negative signs. So we're going to have 0 minus a negative 6. Depending on how you learned your integers, you could look at this two ways. So the way I look at it is whenever I see I have a double negative here, so subtracting a negative, they cancel out, and that kind of just flips on up, and it becomes a positive. It ends up becoming 0 plus 6. Maybe you learned about it through keep, change, change. You'll get the same result. If you use keep, change, change, you keep the first number the same, change your subtraction sign to addition, and then change your second number to have the opposite sign. The opposite of a negative 6 is a positive 6. Looky there. Two ways to look at it, same result. 0 plus 6 would be 6, meaning 10 to the 6th is what we get when we divide those. All right, now let's divide our coefficients here. Let's divide our number terms. Remember, it's 0 8/10 divided by 0 400. The 0 8/10 is being divided by the 0 400. When we have a problem like this, when our number that we're dividing by is also a decimal, we have to change that first. We can't do that division. And we change it just like we do with lots of things by moving that decimal point. So in order to make this number not a decimal, we need to move it 2 places to the right. And whatever I do to one number, I have to do to the other. I have to keep it balanced. Otherwise, I'm just using magic and creating a brand new problem, and that's not going to work. We also need to move this 2 places to the right, giving us a new problem of, we'll fill in this empty space with a 0 here, of 80, and I'll put the decimal there in case I need it, divided by 4. All right, if you happen to know what 80 divided by 4 is, cool beans. If not, go ahead and do that long division because the number we're dividing by is no longer a decimal. 4 can go into 8 2 times. Evenly, bring down the 0. 4 can go into 0 0 times, leaving us with the answer of 20. So now that we have divided both our number terms and our power of 10 terms, let's put those 2 pieces back together. And we have 20 times 10 to the 6th. Is that our final answer? No, it is not our final answer. What is wrong with it? It is not in proper scientific notation. So that 20 right there, that is definitely not less than 10. All right, but where's the decimal point? Because I don't see one at all. At the end of the number. Remember, if we only have values of 0 that follow our decimal point, we don't need to write it. Unless we're talking about money, then sometimes we do. But it's really right here. Well, if I move it to the right, that's just going to make my number bigger. So therefore, let's see, if I move it 1 time, that gives me 2.0, otherwise known as 2. That works, yeah. So I only needed to add 1 decimal point. So make sure you add that. Up here, we added a decimal point. 6 plus 1 is 7, giving us our final answer of 2 times 10 to the 7th power. Okay, that is the end of our video lesson here. Make sure that you now go forth and complete the activity that's aligned with this. All right, make sure that you go and complete that quizzes to get some practice in. And then this is your regular assignments for the week. Make sure that if you haven't already finished your 104 Learn and Practice, you do so before our next time that we meet, so you can have a full understanding of the unit, and then any questions you may have can hopefully be answered in class, and you can bring those up. The graded assignment that goes along with this is IXL assignment YZU, multiplying numbers written in scientific notation. And then, of course, if you have not yet completed your diagnostic snapshot, earned those 6 stars, make sure you keep working on this overdue assignment. You can earn those points. All right, if you have any questions, please feel free to reach out via email, or of course, you can check in with me during a help session. Have a great day and good luck on your next assignments.